Before a submarine submerges, the crew always follow a set procedure called rig for dive. Each point on this checklist is checked by a crew member and then double-checked by another crew member. As the submarine dives, the crew check all areas for leakages and report them to the warrant officer. A similar procedure applies to confined spaces. Check all potential hazards and constantly monitor the confined space to reduce risks. How do we identify the hazards in confined spaces? Examples of confined spaces include spaces on board ships, in silos, containers, vaults, low areas, or channels around piping. They all have a number of common features. They all have restricted access and are unsuitable for long-term occupation by people. There are several risks associated with working in a confined space, which include injury due to a hazardous atmosphere inside the space, drowning or suffocation due to the presence of liquid, gas or movable solids and fine particles such as grain, entrapment caused by an unusual shape such as a sloping floor, walls which form a funnel, or overhanging ledges, injury caused by moving machinery, electricity or extreme heat or cold. All these hazards can lead to accidents, which could be fatal, so it's important to understand the dangers and how to avoid them. Atmospheric hazards mostly mean too little or too much oxygen, compared to the 21% volume in our normal atmosphere. If there's too little oxygen, people can become disorientated, confused, or too weak to vacate the area, whilst too much oxygen increases the risk of fire and explosion. A hazardous atmosphere may also mean that the area contains harmful levels of hazardous materials, which could intoxicate or poison you. Prior atmospheric testing is therefore very important. The atmosphere inside a confined space must always be tested several times. The first test is aimed at measuring the oxygen level. Then the air is monitored for combustible gases and vapors. Finally, the space is monitored for toxic gases and vapors, which can cause acute or chronic illness. Gas testing must be carried out from top to bottom, because heavier gases accumulate at low levels, whilst lighter vapors rise to the top. Atmospheric testing determines what measures or aids are needed in order to be able to work in the space. For example, extra ventilation may be sufficient. In some cases, the space may need to be emptied under pressure using a rare gas, such as nitrogen, to dissipate combustible vapors. However, in doing so, you create a space with a low oxygen level, where it's only possible to work with breathing apparatus. Examples of other hazards include a fluid-filled tank in which you can drown, a grain silo or a store of other fine particles which can act like quicksand, or the explosive hazard caused by liquid gas. The space can sometimes be hazardous due to its shape, because the floor may slope upwards or the ledges overhang, making it difficult to escape quickly. Other hazards which make a confined space dangerous are electricity, moving machine parts, or high temperatures. Safe systems of work which aim to minimize risk include lockout-tagout procedures for electrical and mechanical machinery, and keeping temperatures to safe levels by pumping cool air into the hot space. All hazards presented by confined spaces must be removed, isolated or controlled before entry is authorized. This permit identifies the space, the scope of the work, and when it's to be carried out. The permit lists all the team members, their duties, and the necessary equipment. The permit notes atmospheric test results and all prior measures that have been taken to guarantee safety. It records precisely which personal protection equipment is prescribed. Furthermore, it gives a summary of all the measures that apply throughout the whole work process. All team members in the confined space must check the permit so that they're aware of the hazards and the precautions needed. Sometimes the permit contains other safety measures or special permits. One example is a hot work permit for welding or cutting work in the confined space. In many cases, people entering a confined space will have to use personal protective equipment known as PPE for short. The work permit shows exactly what sort of PPE is prescribed, such as gloves, hard hats, safety shoes, safety glasses, fall protection, or ear defenders. Other equipment can be more complex, such as independent respirators. The type of PPE you'll need depends on the specific hazard and the type of work to be carried out. When working in confined spaces, good communication with colleagues outside the confined space is essential, sometimes by talking, directly or via a radio or mobile phone, or by using a signaling system. Some workers wear special equipment which records movement and emits an alarm signal if movement stops. Many employers demand that staff wear personal fall protection equipment. This can make it easier to rescue a person in difficulty from the confined space. For vertical entry, a mechanical hoist must be installed so that people who get into difficulty can be rescued directly without entering the confined spaces. Even if you follow all the precautions, accidents can happen. So it's important to know what to do if you have to evacuate the confined space in an emergency. A team carrying out work in a confined space comprises an attendant, whom the workers keep at the opening to ensure that it's safe, the people who enter the space to work, known as the entrance, someone who oversees the entire operation and ensures all permit requirements are fulfilled. Finally, there must be a rescue team on standby in the event of emergencies. We begin with the duties of the attendants. As an attendant, you remain outside the area to monitor people who are engaged in the work. You must be trained to recognize the signs of a problem and to take action where necessary. Many employers train their attendants to read a gas monitor hanging at the opening of the confined space. This monitor regularly indicates the atmosphere inside the confined space and can serve as an early warning if the atmosphere inside the confined space becomes hazardous. You should give the order to evacuate if you observe conditions which are not allowed in the work permit. Whenever you notice abnormal symptoms in one of the workers, or if you see a situation outside the confined space which could represent a hazard, and whenever there's any other reason why you can't carry out your duty safely. During an emergency, you may be tempted to rescue a fallen colleague. However, you must always remain outside. Many well-intentioned but untrained rescuers have lost their own lives trying to rescue a colleague in trouble. The attendant is the person who summons the rescue team and begins the rescue using the equipment available. Then there are those who enter the confined spaces and do the work. Your first duty as an entrant is to avoid hazards. This is why it's so important to read the permit thoroughly. The permit lists the hazards you may face. See that you know what to do if problems occur. For example, do you know the symptoms of a lack of oxygen, nausea, lightheadedness or disorientation? To work safely, you yourself must also check that all hazards are controlled. Is the machinery actually switched off? Do you have a sound lockout-tagout procedure? Is the access securely blocked off? Can the work you're doing create a new hazard in the space? For example, using up the available oxygen by hot work or extreme exertion. Your safety in a confined space is a responsibility that you share with all other team members. The rescue system used with a vertical entry is a hooked belt with a rescue line midway between the shoulders. If you remove one of these aids, the attendant won't be able to hoist you up in an emergency. If the attendant or supervisor orders you to evacuate, stop what you're doing and get out immediately. If a problem occurs, warn your colleagues and inform the attendant. If one worker finds it necessary to vacate the space, everyone must go outside. If this happens, leave the space immediately. The role of the entry supervisor is to ensure that the permit and all tests and procedures are complete, to ensure that all equipment is in place, to oversee follow-up tests, and to check that rescue equipment is in place and is working. Another duty of the entry supervisor is to keep unauthorized persons away from the confined space. Before anyone may enter the confined spaces, the entry supervisor must be sure that everything is ready and the permit signed. The entry supervisor is also authorized to terminate the permit when the work is finished or if a problem arises. If an entry supervisor is in any doubt about the hazards in the confined space, no one may enter until they're certain that everything is in order. In this program, we've covered the hazards in confined spaces and the duties of the team carrying out the work. Each member should know the hazards and follow the instructions in the work permit. Each person must use prescribed safety equipment and know what to do if a problem occurs. If all team members are well prepared, work can run smoothly and safely, not based on good luck, but through training and caution, knowledge and trust. In fact, working in confined spaces has a lot in common with working in a submarine. It takes good teamwork to ensure that everyone comes out safely.